First, let's take a look at the location that we're taking all of our nuclear weapons to. The Marianas Trench is located in the Pacific Ocean, around 124 miles east of the Mariana Islands. It's a crescent shape that measures 1,554 miles in length and 44 miles wide. The maximum known depth inside the trench is 36,204 feet, almost 7 miles down, named Challenger Deep, a small, slot-shaped valley at the southern end of the trench. To give you an idea of how far down Challenger Deep is, we could place Mount Everest, which is 29,035 feet high above sea level, into the trench, and the peak would still be 1.3 miles underwater. If we're going to detonate all the nuclear weapons in the trench, we might as well pick the best place for what would be the largest nuclear explosion on the planet. The Mariana Trench is the deepest, darkest place on Earth, and part of the Izubonin-Mariana subduction system, and forms the boundary between two massive tectonic plates. The ancient Pacific plate is slowly sliding under, or is being subducted under the smaller Philippine Sea plate, which is forced to sink due to high gravitational energy into the mantle. As you might imagine, the Mariana Arc has frequent moderate to large earthquakes that range in magnitudes 7+ on the moment magnitude scale. Some of these earthquakes are incredibly powerful and happen at different depths, many deep inside the Earth. Now it's time to move on to the nuclear arsenal. We need all the available nuclear weapons in the world, gathered from every country that has them. In countries like North Korea and China, there is no way to know exactly how many nuclear weapons they really are, or what the actual yields of the weapons are. So we'll stick to what we know for sure. Keep in mind that today's nukes are nothing like the first nuclear weapons named Gadget from the Trinity test, which was detonated on July 16, 1945 in New Mexico, USA. Modern warheads and bombs are the most devastating weapons known to man, and a single nuclear mass destruction device could level an entire city. Currently, there are 3,750 active nuclear warheads worldwide, and about 13,500 total nuclear warheads different countries possess around the world. These bombs and warheads vary in strength and can have an explosive yield range of 0.3 kilotons to 1.2 megatons. The United States and Russia hold around 88% of the world's stockpiled nukes. Using an overall average of 0.54 kilotons, it's estimated that these weapons would have a total combined power of around 6,600 megatons. Add the other 1,260 nuclear weapons possessed by other countries using the same equation, and we end up with an explosive total of around 7,300 megatons. How much damage would all these weapons cause if detonated all at once? It would be hard to imagine such a huge explosion. To get an idea, let's look at the explosive power of some of the most powerful nuclear bombs ever built in the world. The largest nuclear weapon ever tested was the USSR Tsar bomber, which is now estimated to have a yield of about 57 megatons, the equivalent to 57 million tons of TNT. If this type of weapon were dropped on a city, let's say New York, the heavy blast damage radius would be 5.1 miles. But there was another nuclear weapon design that not many people know about that would have been 200 times as powerful as the Tsar bomber if it had been built. The United States detonated a nuclear bomb at Bikini Atoll in the Pacific on March 1, 1954, that resulted in a 15 megaton nuclear explosion that was twice the expected yield. But as powerful and terrifying as it was, the explosion was just 1/3 the size of Tsar bomber. But one of the scientists that helped build the Castle Bravo weapon was aiming for something even more powerful. A 10,000 megaton weapon that would have been 670,000 times more powerful as the bomb dropped on Hiroshima. So large that it would have destroyed a continent and poisoned the Earth. However, blowing up the world's nuclear arsenal on the surface of the planet somewhere is going to have a much different effect than blowing them all up underwater. There have been tests of nuclear weapons underwater done before, such as Operation Hardtack in 1958, and the deepest underwater nuclear bomb test was Operation Wigwam in 1955, which used a 30 kiloton warhead, which was detonated at 1,968 feet below the ocean's surface. The most destructive part of these explosions was the radioactive water. If we put our 7,300 megaton superweapon in Challenger Deep and then detonate it, it would produce a huge bubble of hot gas, which would then collapse quickly under the crushing pressure of 6 miles of water overhead, which equals around 8 tons per square inch, or about 1,000 times the standard atmospheric pressure at sea level. This is also assuming the super nuclear weapon survived the crush depth in the first place before it was detonated. So how do we detonate all these weapons at once? Edward Teller and Stan Ulam came up with what's known as the Teller-Ulam designs, which links nuclear devices together, a useful design for our experiment. In theory, you could link an infinite number of sub-bombs together to make one giant bomb. Teller was aiming for a Tsar bomber from the beginning, and the explosive force of the superbomb being contemplated would produce an explosion equivalent to 100 million tons of TNT. The explosive force of this kind of weapon would be enough to destroy most of the entire state of California. One weapon would destroy all of the UK and Ireland, the entire country of France, all of Germany, or both of North and South Korea. But even at the estimated total of 7,300 megatons, all of the weapons placed in one big pile would do almost nothing to the trench. Using a formula from a 1971 paper called The Evaluations of Various Theoretical Models for Underwater Explosion, the blast radius of this underwater explosion would be almost miles across, and a 10,000 megaton weapon would have a blast radius of 62 miles. Both explosions would be incredibly huge. Would massive earthquakes start? Or maybe some tsunamis? While it might seem like explosions of these magnitudes would create total chaos, you'd need a lot more than a 7,300 megaton weapon to do much damage. And putting all the weapons in one spot and detonating them would be far less efficient. Here's why. When plates at a fault line move, the entire plates move against each other for miles and miles, not just one small section. This would mean that you'd need to use the Teller-Ulam design and spread the nuclear weapons out in an actual chain and along a big stretch of the fault line. But then you'd lose your explosive power as the bombs are spread out. At this point, there just aren't enough weapons to do anything spectacular. We definitely wouldn't see something like this. In fact, the trench is so deep that we wouldn't even notice anything at the surface. No explosions, no bubbles, nothing. So, what would it take to cause worldwide damage? The Chicxulub impact event was estimated to be a 100 million megaton blast which devastated the Gulf of Mexico region. The impact left a crater 93 miles in diameter and 12 miles deep, well into the continental crust. The impact produced a seismic pulse equivalent to a magnitude 10 earthquake. And even though there was massive damage and the asteroid almost took out all life with it, the Earth kept spinning. If a 100 million megaton device with the same blast force as the Chicxulub meteor was detonated in the Mariana Trench, there would be a giant hot gas bubble 140 miles across. The oceans aren't this deep, so it would blow a hole into the Earth's crust miles across, and would leave a hole where you'd briefly see glowing magma from the mantle. The blast would create waves 2.5 miles high that would cover the forests of California and the Pacific Northwest, Indonesia, along with most of the coast of China and the Pacific Rim. Huge amounts of rock and water would be blasted into space, and giant chunks of rock as big as houses would heat up in the atmosphere and, like meteors, would fall back to Earth, causing global firestorms. The hole in the bottom of the trench would fill back in with water, causing huge columns of steam and massive earthquakes. The trench is now gone, along with the Guam and the Mariana Islands, the blast leaving behind a 124-mile scar of sizzling magma. It would be no less devastating than Chicxulub itself, and most living creatures would die. The good thing is that we don't have to worry about any of this happening. For one, we don't have that kind of nuclear capability, and secondly, we seem to be lucky there aren't any planet-killer asteroids headed our way that we know of. But that could change at any moment. Speaking of asteroids, make sure to check out our Apophis video. We'll leave a link in the description for you. One thing that we know for certain is that Earth is very strong, and human weapons are puny compared to what the planet has been through.